All right, folks, we're going to continue with lesson 3. The lesson 3 activity sheet. You click on here and it'll show this, and later it'll show the video down here below. All right, I've already downloaded it, so I'm going to click Kami and I'm going to open it on up like so. Here's what it looks like. No, thank you. We're going to use graphing calculators to answer questions 1 through 3 about a graph to solve the inequality, this inequality right here. Wow, look at that fun thing. Okay, so let's pull up Desmos since it's a graphing calculator. Desmos. Here's a calculator. And now we're going to go over here and we're going to take a look at this. So we're going to solve, let's think about what it's asking. We're going to use our graphing calculator to answer the questions to solve the inequality this. Okay. We're going to let y1 equal the first half of that equation and y2 equals 75. So when what we're doing is these two things combine to make that. I hope that you see that. So we're going to graph this. We're going to graph that in a moment here. Okay. We're going to graph this guy, y1 and y2, except I'm going to use y, just regular y. So y equals, what was it? It was 2995.16x. 2995, oops, 95 plus 0.16x. Boom. There is my first equation. It's not even on the graph. What's going on? We'll get there in a moment. So I just typed this in. Now I'm going to do this one. Y equals 75. That's easy. Y equals 75. Now I have to pause because someone is ringing my doorbell here. And we're going to figure out what that means in the graph. Pause for now. All right, well, I'm back. And I will tell you, I recorded a whole bunch and then I found that it wasn't being recorded. So we're going to go over what we wrote. Okay. So it'll be faster. I meant to type this in. I did earlier, but oh well, life goes on. So we're talking about the dune buggy problem from earlier. Okay, so that was like this guy and he was dune buggying and it cost $29.95 to rent the dune buggy and it costs 16 cents per minute and he's got like $75 and blah, 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 blah. Okay, that's where these numbers are coming from, just for the record. So that's what we're referring to. And so here's the cost that it said. This is how he finds out what he's getting charged. $29.95 plus 16 cents for every minute. And then $75 we said was the amount of money he has to spend. So if I want to find out what y1 equals y2 is, the trick is I find out what y1 equals and I plug that in. I find out what y2 equals and I plug that in. This is what that's referring to. The amount that he gets charged, this is the amount he gets charged, equals $75. The formula tells how much you get charged, makes $75. So this is when the person wants to spend exactly $75. However, here, the amount he's getting charged is less than. Remember, this inequality points at the smaller number, opens toward the bigger number. So if you're looking for an inequality, always remember that. That's much better than greater than less than. Because the only reason we say this is less than is because we read left to right. 29.95 plus 0.16x is less than 75. However, if I was going from right to left, it would be 75 is greater than x times 1.16 or blah, 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 blah. Doesn't matter. The point is, knowing which way it's pointing is much more important than like knowing which one to call greater than and which one to call less than. Okay? Because the whole point is that it tells me which number is greater or smaller, no matter which direction I'm reading it. Okay? So the person wants to spend less than $75 because here's the amount he spends, and that's less than $75. So that's what I'm saying. Here we have the amount he wants to spend. That's greater than $75, more than $75. Okay? So that's what's going on. Hopefully that makes sense. Now we're going to get onto this problem. Using our calculator to check the solution, what do X represent and Y represent? So here's our calculator checking it. In fact, I'll use this because they've got it all set up. So I might as well use Agile Mind real fast. In Agile Mind, they made a graph. Look, this is the formula for how much it gets charged. If he graphs it, it looks like this. It has a y-intercept of $29.95, about $30. And it goes over, for every 1 minute, it goes up 0.616 or 16 cents. So by the time he's driven 200 minutes, it costs about 60-something dollars. Okay? And now we've got this thing right here. That is $75. That's the graph y equals 75. Okay, so now I have one graph, y equals 75, and another graph, y equals this whole lovely thing. All right, here's what it looks like if I graph it on Desmos. It's the same thing. Look at that, looks very familiar, doesn't it? Okay, so if I type y equals this, now what does y represent? Well, y represents how much he's getting charged. And x represents how long he's driving this thing for, how many minutes have gone by. So after 100 minutes, he's getting charged 40-something. After 200 minutes, he's getting charged, 62 or something, and so on and so forth. What we're asking is, when is he going to get charged $75? Okay, so that's what we've got. X represents time in minutes. Y1 represents how much they pay for the dune buggy rental. Okay, and now we got this number right here. I'm actually going to change it to 25 because that's correct. Okay, here they rounded it, so it says 0.63. But if I'm in Desmos, a cool trick you can do is if I see two lines and I want to figure out where they graph, I can zoom in. First of all, that helps. Notice $80, $70. This is 75, and we're at about 280 or 290, somewhere around there. 280, 282, 284, 6, 8, 10. So this is somewhere between 280 and 282. Where is it? Well, the cool thing about Desmos is if I click on there, look at that, it tells me where they cross. The blue one is at 75. So we're at 75 to the on the y-axis, and on the x-axis, if I go straight down, that's 281.5 basically. 281.563 or 25. Okay, so that's pretty cool, isn't it? Going back to here, 285. Now you could say 0.6325. It's rounding is what changes that. It's originally 2.5, and you'll see when we do it with algebra, we can get the exact answer, but you can't really see the exact answer so well on the graph. So it is what it is. All right. So is it possible to have a number of miles be less than 0? The answer is no. I'm just telling you right here. This is very important in geometry class. In geometry class, you will discuss the nature of distance, and this is a fact about it. There are some things that are always positive, and there are things that are negative as well. Temperature can be positive or negative. However, change in temperature is always an amount. Whenever we're talking about amount of something, we don't say whether it's positive or negative. If I move 10 feet, it's 10 feet. It's not negative 10 feet. I can move 10 feet up or 10 feet down, but I'm still just moving 10 feet. Distance is always a positive, okay? Oh, did I say minutes? I've been saying minutes all this time. He drives a certain number of miles. Okay, I'll remember that for the future. M is miles. I think there's some typos in here. Okay, so we got this right here. Actually, it was right here, wasn't it? Let me fix that right now. X represents miles driven. I can't believe I made that mistake for that long. Oh well. You think of something and you run with it. Okay, so now we're going to solve it. Here's what I want you to understand. We can solve inequalities the same way that we solve equalities. Okay? Since I'm going through here again, I might as well make this prettier. One way, if you're typing, I don't mind if you type this less than or equal to, less than or equal to, perfectly okay with me. But since this is the key, I might as well make it pretty, all right? So we can also just put that down and go like so. Now we're going to talk about why you're allowed to do the same rules for this as for equal signs in a moment. But suffice it to say, while I'm writing this out, that what we learned earlier was that if two numbers are equal, right, or if two amounts are equal, and I add the same amount to them, then they stay equal, correct? Now imagine one of them is bigger than the other. You add the same amount to both sides. Is it going to make the other side bigger than it's going to switch which one's bigger? No, it's not going to affect which one's bigger at all. So we can use the properties of equality on inequalities as well. Okay, so we've got this. I did this already. It's very important to notice. M is less than this. Remember, we always mark the number, and then we mark M or X or whatever. That's all of the numbers that are less than that number. So 281 is right here. Anything less than it. Now here it says 0 is less than M is less than 281. M is literally between 0 and 281. Okay, it's greater than 0. All the numbers bigger than 0 and less than 281. So I mark all of the numbers that are bigger than 0 and less than 281, and bada bing, bada boom, there we are. Notice I filled in the dots because it's equal to them as well. And we'll have more practice with that, I bet. And then we have a cell phone company. I did this earlier too. You're getting charged $25 a month plus 15 cents per minute. And he has a monthly bill that's over 55. So what I did is we said, here's how he gets charged, $25 plus 15% per minute. And that, the cost he gets charged is bigger than 55. And now we can just solve it like an algebra problem. I can take 25 from each side. I can divide both sides by 0.15, and I get 200. So this is the number of minutes he talks on the phone. So he gets charged more than $55. Means that he talked more than 200 minutes on the phone. And we can figure that out. If he got charged exactly 55, that would mean that he exactly 200 minutes. So really, it's just a language thing. Most of the math is exactly the same. Okay? So don't overthink this stuff in the future. Okay? The algebra is the same. Equals and inequalities, equalities and inequalities are almost all the same. There's just one special rule that we're going to get to in a moment. How could I solve this? Using a table? Well, I might make a table like this, 100, and use this formula. The amount he gets charged is $25 plus 15 cents per minute. So if he talks 40 minutes, multiply by 15 cents, add 25, and I get 100 minutes costs $40. 120 minutes costs 43. I realized, hey, look at that, 20 minutes is $3. Now I can just go 20 minutes, $3, 20 minutes, $3, all the way up to 200. 200 minutes is $55. Look at that. I solved it. That's one way you could do it. You could also graph the lines. Graph this one and that one. I can type them into Desmos. Y equals 55. And where'd you go? And y equals 25 plus 0.15x. 5x. Let's see where they cross. Here's where they cross. 255, in other words, 200 minutes costs $55, just like we found out using algebra. Okay, so that's another way you can solve it. I mean, technically, there's some problems with solving it this way. Pretty big graph. right? And it's all way over here, and it's in the hundreds and all that fun stuff. It would not be fun to graph this by hand. It only works because we can use Desmos, really, right? So it's probably algebra is better. Okay, so now we're going to talk really quickly. We know that 2 is less than 8. On a number line, 2 is right here, 8 is right here. 2 is less than 8. It's further to the left on a number line. Remember that rule? Okay, so if I add 1 to each of them, now I have 3 and 9, which is bigger. 9 is still bigger than 3. What if I have 4 and 10? The one on the right is still bigger. Will that ever change? And I would tell you no, because always the number on the left still, I have to add 6 to get to the number on the right, because they're staying the same amount apart. It's like I move this guy over 1 to 3, this guy over 1 the same way to 9. They're still the same amount apart. They're still 6 apart, 6 between them. I can't write, but you get the idea. Okay, so what does that mean? Well, that means that this will always point the same way. So when I'm adding the same amount to both sides or subtracting the same amount from both sides, it always points to the left because the smaller number stays in the same spot. And that's what this says right here. The number on the right remains the greater number. It stays 6 larger than the number on the left. And here we have, what about multiplication and division? Oh yeah, here. What do you notice? The number on the right remains. This is if you subtract. So the property of addition, property of inequality, I mean, you could call it that, but it's not really a big deal. So this is like basically the addition property of equality that you learned earlier works with that's basically what we're saying. Okay. So you can use that. You can use that tool that we learned for equalities. We can use it with inequalities. Same thing goes for subtraction property of equality. Okay, so those are 2 things to realize. However, when we multiply, things are a little more complicated. This is the big one, and I wrote it in red down here as well. We can also multiply and divide by the number. Notice if I have 2 times 1 and 8 times 1, 8's going to be a bigger number. 8 times 1 is going to be a bigger number. I have 2 times 2 and 8 times 2, 8's going to be the bigger number. 16 and 4, 16 is bigger than 4. So it doesn't switch which one's bigger when you multiply either, or when you divide. 2 divided by 2 is 1. 8 divided by 2 is 4. 1 is less than 4. So as long as 1 starts bigger, and I multiply, add, subtract, divide by the same number, it's going to remain the bigger number. The arrow will point the same way. However, when I multiply by 2, notice these numbers start out as 2 and 8, right? If I multiply 2 times negative 1, it moves to negative 2. And 8 moves to negative 8. Now, this guy's bigger because he's further right on the number line. So the arrow has to point the other way. Negative 2 is bigger than negative 8. So when I multiply by a negative, or just for the record, divide by a negative, it switches which one's bigger. Because 8's such a big number that when it turns negative, it's a larger negative number. But that's not the way we look at things on a number line. We look for the number further to the right. So 2 becomes negative 2, which is the larger number. This points the other way now. Okay, so you'll notice when I multiply or divide by a negative, the arrow points the other way. It switches which number is bigger. That's a very important thing. That's the one big rule that's different for for inequalities. Everything else works the same way that equalities do. So we solved equations. Everything works the same when you have an arrow in there, when you have an inequality, except for one. When we multiply by or divide by a negative on each side, it switches which number is larger. So we have to point the inequality in the other direction. We always switch the way it points. So here's a good example of that. I'm solving this. I subtract 8 from both sides. I end up with negative 2x is greater than 6. I divide by negative 2, but I divide it by a negative. So when I go to the next step, I do everything just like algebra, but I have to turn the arrow in the other direction. That's why that's a rule of solving inequalities. You have to turn the arrow around. Hopefully that makes sense. And now I'm going to stop and publish this one before it erases somehow again.